There are basically three modes of heat transfer. The first one is conduction, where the heat transfer occurs between objects or surfaces that are in direct contact with each other. If there is no contact between the surfaces, there is no heat transfer happening by conduction. So for conduction to occur, the objects or surfaces should be in direct contact with each other. And heat flow is always from the object at higher temperature to the object at colder temperature. Metal needle getting heated up when it is in contact with a flame is an example of conduction. Conduction occurring at the point of contact, the temperature would be very high, but you will, after you hold it for some time, you would feel the heat even at the point where you are holding it, because within the metal there is heat energy flowing because of conduction. There is the same example, only to show that as the distance from the source of the heat increases, the temperature drops down. One reason for the temperature drop would also be the heat loss to the surroundings if it's not insulated. Then the second mode of heat transfer is by convection, where heat transfer by convection is occurring because of density differences within the fluid, actually, because of temperature profile differences. This is heat transfer within a fluid. It can be a liquid or a gas. Convection does not apply to solids. Conduction applies to solids. So this is heat transfer within a liquid or a gas from a higher temperature to a lower temperature. How does this heat transfer occur? This occurs due to molecular motion, movement within the fluid. And on what basis does that molecular movement occur? It occurs because of the temperature differences, which creates the density differences. And that is why the molecular movement happens within the fluid, whether it's a liquid or a gas. One good example would be heating. If you are heating water in a pan on your stove, then the convective currents are set up by the warm water at the base rises to the top because it is lighter, it is less dense now. And the space created by the warm water rising up, the cold water from the top comes and fills up that space. So that is how you have convective current setting up within the water, within the molecules in that water. Now, the third mode of heat transfer is radiation. Unlike conduction and convection, radiation does not require either a medium or a contact. It simply happens through electromagnetic waves. There is no contact between objects and no molecular movement involved in radiation. So it does not involve the medium. Heat transfer by radiation occurs even in vacuum. It's not necessary that there should be some medium through which radiation occurs. It's not required. The medium is not required for radiation. The best example for radiation would be the sun's heat on the earth. How we receive the sun's heat is by radiation. How we feel the warmth of a bonfire, even though you sit at a distance, is by radiation. These are two good examples which we can relate easily. Now, what we have seen, the examples are for each individual mode occurring, either conduction, convection, or radiation. But everyday life, all three of them occur together also. This is the best example. You are heating a liquid in a pan, the flame, the bottom of the vessel being heated up by seeing the flame. That is what you have radiation by. Within the walls of the pan, you have conduction. And within the liquid inside the pan, you have convective currents, convection setting up. On an industrial level, if you see, this is an example where you are heating up water in a closed loop system, in a closed pipe, by firing some fuel. That is where radiation is involved. Then that water is being used to heat up an oil bath. So the transfer of heat between the water and the oil is occurring across a thin tube wall where conduction plays a role. And within the oil, you have convective currents. So all three are involved in this system. There is again an example of a fired heater where the hot fluid is being used to maintain the temperature of the contents of a reactor. Within the heater, you have radiation. At the reactor wall, you have the conduction occurring across the wall, and within the reactor, inside the reactor, the contents are maintained because of convective currents which set up.